Hi everyone, welcome back to my channel Mathematic Girls Swati 3226. So in this video, I'm going to talk about vectors. This is a topic from class 12, of course. So this video is basically like an introduction to vectors, the very basic video, and this is the first part of the video. So let us understand how these vectors have come. So we know a lot of physical quantities, right? Like distance, time, temperature, acceleration, force, mass, a lot of quantities we know. These are all physical quantities. So these physical quantities that we know, that we have basically divided into two categories. And as soon as I say two categories, you must have understood I'm talking about the two categories scalar and vector. So the first one is called scalar quantity, and the second one is called vector quantity. So today we are of course going to talk about vector quantities. So I'll just tell you in short what is the meaning of scalar quantity. So the meaning of scalar quantity, like those quantities which have only magnitude, okay, no direction. So scalar quantities are those quantities which have only magnitude but no direction. It has no direction. Sorry, you have to cancel it because it has no direction. So for example, like which quantity which has only magnitude but no direction? For example, temperature, right? You can say that temperature is a scalar quantity. Why? Because temperature only has this magnitude, like 25 degrees Celsius, 10 degrees Celsius, 40 degrees Celsius. So it's just the magnitude that we are talking about. We never say that 42 degrees Celsius towards north, 19 degrees Celsius towards south. No, we never call, like we never say temperature like this. So that is why it is categorized as scalar quantity. So scalar quantity is very clear, those quantities which have only magnitude but no direction, unlike vector quantities. So let's talk about vector quantities. So in vector quantities, it has, like you can say that all those quantities which have both magnitude as well as direction. Okay. So the quantities which are having both magnitude as well as direction is called vector quantity. For example, force. When we are talking about force, we sometimes say that like someone is applying a pressure force of 10 Newton, right? But that has a direction. We apply force towards, like north, south, east, west, or you can also say towards bottom, towards up. So whenever we are talking about force, we are always talking about magnitude as well as direction. Okay, because when we are talking about force, we have to be very specified, about its magnitude as well as its direction. So that is why force is categorized as the vector quantity. So I hope the difference between scalar quantity and vector quantity is very clear. Now let us talk about vector in detail. So first of all, let me tell you how do we represent vector. So now we are going to understand representation of vectors. Okay. So in this video, I'm not going to take any question. I'm just talking about the basics of the vectors. So yeah, for the questions part, I'm going to make another part where I'll be talking about I'll be solving a lot of questions also for you, and those questions will be NCERT. Okay, so let us understand how do we represent vectors. So for that, let me take, two points. You can also say that suppose we have two nails, okay, A and B. Now suppose we have a string also, which we are using to attach both the nails A and B. Okay, so let me draw a string. Okay, so this string here is nothing but it is a line segment. It is basically a line joining both the nails A and B. Okay, so here this AB. Okay, let me write down here. So this AB is basically representing a straight line segment joining the point from point A to point B. Okay, from here we can actually understand the concept of a vector from the very basic. Okay, so if you're treating this AB as a very small line segment, okay, of any length, so let us assume that this is point A, of course, and this is point B. And the direction of AB here is this. Okay, so here I'm specifying the direction A to B, right? It is absolutely going from A to B. We are assigning an arrow head directed from A to B. So that has a magnitude. Suppose it has a magnitude of 5 centimeter. Let us take, and it has a direction also towards B. So that is why this is of course a vector, and we can represent this vector as AB with an arrow on the top. Okay, so this is how we represent a vector. Now let us look at the same line segment A to B. Okay, this is point A, this is point B, and I am drawing a line once again, but this time I am changing its direction. What is the meaning of changing the direction? Now the arrow is directing towards A. So we have this point A, we have this point B. So we can represent, of course, this has also, some length, suppose 5 centimeter. So this has a length, magnitude, as well as direction. Now this time it is pointing towards A. So this is a vector AB again, but with the direction towards A. Okay. If you want, you can also represent it by writing BA, but remember the arrow should be towards A. So this is how we represent the vector. Here, talking about this particular vector AB, okay, which is for this, and this particular vector BA or even AB with the opposite direction. For this, you can simply say that here AB and BA have same magnitude. Okay, maybe it does not look like the line segment is not looking like the same, but imagine it's the same. It is having the same magnitude, 5 centimeter and 5 centimeter. Both are having the same magnitude, but it has opposite direction. This one is heading towards this, another one is heading towards this. So this has a opposite direction. So this is the representation of vector. Now there is one more very important thing that I want to tell you, that suppose I have a vector, one second. Okay, so suppose I have a vector here, OA. Okay, I'm writing this as O and this point as A. Okay, and suppose the direction is towards this. So I can also denote this as by a small letter A. Okay, so this you have to denote by A vector because the direction is of course towards this. So this way you will represent. Now this is representing the direction of this vector. Now, if you want to write down, suppose the length of this is 10 centimeter. So this you have to denote by magnitude, and this is how we denote the magnitude. Okay, here A is representing the magnitude, or if you want, you can also represent it by writing OA, which is OA in the direction of from O to A, so this way, and then the magnitude is 10 centimeter. So this is how we represent the magnitude of the vector. Okay. So remember one more thing, that whenever we are talking about the magnitude, we are talking about the distance or the length. Remember, the length can never be negative. It can either be 0 or it can be more than 0. So therefore, we can also say that the vector, for example, I'm taking here OA only. This has to be greater than, or it can be equal to 0 as well. Because if it is equal to 0, it has like it has basically a name. It is called something that I'll explain when I'll talk about the types of vectors. So remember, in this case it has to be greater than 0 only because it is 10 centimeter, of course you can see. So remember, length cannot be negative. Okay, because like Okay, this one, OA lesser than 0, this simply means, okay, this has no meaning in vector. Okay, this has no meaning in vector. So therefore, the vector OA should always be greater than or equal to 0. Okay, here I'm writing just greater than 0, or if you want, you can also write down this. Okay, so why equal to 0? Because that is a type of a vector that has a name, which I'm going to discuss just now. So I hope the representation of vector, the how do we represent the vector, what can be the possibility of the magnitude of a vector, all these parts are clear. So let us go to the next part, which is types of vectors. Now, before I move ahead, I just want to tell you that because I was not well, so that is why I'm keeping my camera off, but still I wanted to make the video for all of you. So here I am. Okay, but yes, because I'm not well, so that is why I have to keep my camera off. Okay. Also, if you are watching my channel for the very first time, and if you have not subscribed to my channel, don't forget to subscribe and keep supporting me. Okay. And yeah, so let's go to the next part, which is types of vectors. So I'm going to discuss a lot of types of vectors. So let us start with the first one. The first vector is called zero vector. Okay. So let us understand about zero vector. First of all, let me tell you how do we denote zero vector. Zero vector we simply denote by 0 and then with the arrow on the top of it. Okay. Now, what is zero vector? A vector whose initial and terminal points coincide. What is the meaning of initial? Initial meaning the starting point and terminal meaning the ending point. Okay. So a vector, if you want, I can write down the definition as well. A vector whose initial, okay, or if you want, you can also use the word like the terms like starting and the ending. So a vector whose initial and terminal points coincide. What is the meaning of coincide? That means it is on the top of each other. Okay. So a vector whose initial and terminal points coincide is called a zero vector. What is it called? It is called a zero vector. Now, zero vector has another name as well, just like we have a nickname. Zero vector also has a nickname. It is also called as null vector. Okay, because the meaning of null is also 0, so it is also called null vector. Okay, now let me explain what does it mean. It simply means that there is a vector A, it starts from here and it ends also at the same point, and that is why we denote such vector as the zero vector. So you can also write down this vector as A, the starting point, and then A as the ending point as well. So we can represent it by AA, right? Because it's the same thing. So AA will be your null vector, which is a zero vector as well. So I hope you have understood the concept of zero vector. There is another way we represent the zero vector, and that we represent as A comma A. Okay? Because it has the same starting and the same ending point. Now let us go to the next vector, which is called the unit vector. As soon as you hear this word unit, you know the meaning of unit. Unit meaning one. It simply means one. So what is a unit vector? A vector whose magnitude is unit. Okay, or if you want, you can also say a vector whose magnitude is unity. Unity is one unit. So a vector whose magnitude is unity. And what is the meaning of unity? The meaning of unity is one unit. Okay. So whenever you are finding a vector, whenever you are coming across a vector whose magnitude is 1, that is called a unit vector. Okay. So this is called a unit vector. Now, unit vector is in the direction of whatever is the given vector. For example, I'll make you understand this concept in a better way by drawing a vector, OA. For example, suppose I have this vector, okay, and this is the starting point O, and this is the ending point A, okay. So this is OA, and because it has a direction, like it has a direction OA like this. So let us understand how it is a unit vector. Now imagine the length of this is maybe 100, okay? Maybe 100 units or like whatever it is. So what is the unit vector here? The unit vector is, suppose from here to here, okay? I'm just marking an arrow here. So suppose this point is, okay, small a. Okay, let me make you understand in a better way. So suppose this point from here to here, it is a vector, okay, A. So this is, okay, this distance is, imagine, 1 unit. So that is why here this OA, okay, that we can also represent it by just small a. So this length is basically 1 unit, right? And this is called unit vector. This we also represent by a cap. Remember here the very important thing is that this vector can be as large as possible, okay? So it may be very large. Suppose it is having a magnitude, as I have written here, equal to 100. But unit vector along the same vector, okay, will have magnitude just unity, that is 1, okay, but it has to be in the direction of this vector only. So suppose this OA is in the direction of this OA has to be in this direction only, okay. So this we represent by a cap. So here it is a unit vector, that is why its magnitude is going to be 1, okay. So yes, when I'll basically cover this topic in the next video, so eventually, or like gradually, the topic of unit vector will be more clear. Okay, so now let us go to the third type, and that is called co-initial vector. Okay, it is like it is sounding like self-explanatory. So what is the meaning of co-initial? Initial meaning the starting point, and co-initial meaning same starting point. So if we have two or more than two vectors, okay, and they are having the same initial point, such vectors are called initial vectors. It is not compulsory that we are only talking about two vectors. Of course, we can talk about two vectors as well, but it can be more than two as well. So two or more than two vectors, two or more than two vectors whose initial points are same, okay, whose initial points are same are called co-initial vectors. Co-initial vectors. For example, I'm going to make you understand by taking one example. So for example, here I'm drawing two vectors, okay, AB and let's say AC. Yes. So you can see here that we are having two vectors, okay. This is AB, okay, in this direction, this is AC. Okay. So here clearly you can see that we have two vectors AB and then AC. Now because AB and AC, these two vectors are having the same initial point, which is A and A, which is here. That is why these two vectors are called co-initial vectors. Okay, similarly, we can have more than two vectors as well. If you want, you can just include one more vector here. Okay, and that is suppose D. Okay, so AB, AC, and even AD. These all three vectors are called co-initial vectors because they are all having their starting point same. Okay, so this is the definition of co-initial vector. Now let us move to the third last type of the uh, types of vector. So that is our fourth vector, and that is called equal vector. Now here this is very, very important to understand. What is the meaning of equal vector? So suppose I have two vectors A and B. Okay, so I have two vector A and another vector B. Okay, I'm drawing it with my free hand only. So these two vectors A and B are said to be equal if they have the same magnitude. That means the magnitude of A should be same as the magnitude of B. Okay, so two vectors A and B are said to be equal if they have the same magnitude as well as they are having the same direction. Okay, so as you can see here, that the direction of A is also towards this and direction of B is also towards this, and their magnitudes are also same. So such vectors are called equal vectors. Now there is very like it is very important to know that like whenever you are defining equal vectors, for example, two vectors A and B are said to be equal if they have the same magnitude and same direction. There is one more very important point to add here, that you don't have to worry about its position. Okay, it can be in a different position, so there is nothing like it should be like it should have the same position as well. No, so the very complete definition for equal vector you can say as two vectors A and B. Let me write down this for you. Two vectors A and B are said to be equal vectors if they have the same magnitude, if they have the same magnitude as well as same direction, or you can write in just same magnitude and direction. And then the very important point, and that is regardless of the position, regardless of the position of, I'm just writing it here, position of their initial points. Okay, initial points. So yes, and we write down basically these two vectors A and B as that vector A is equal to vector B. Okay, so this is how we denote. For example, I can also make you understand that it it can look like this as well. For example, if I'm drawing these two vectors, okay, so just imagine that this is like this line is going here and then this line is going here, and then we have a vector here like A, this one is B, this one is C, this one is D. Suppose the direction of the vector AB is towards this and direction of the vector CD is towards this, and the magnitude of this vector AB is 2 meter and the magnitude of this vector CD is 2 meter also. So here you can see that the position, the initial points of these two vectors AB and CD are not same, but their directions are same, their magnitudes are same. So here clearly vector AB is equal to the vector CD, and these two vectors are equal vectors. Okay, so remember that the position The initial position does not matter here. Okay, now let us go to the next vector, the second last type, which is the fifth type, and that is called position vector. This is called position vector. Let us understand about position vector. So suppose we have a point P in in the space. Okay, so for the space, I'm going to draw this. Okay, now imagine that this is point P. Okay, and imagine that this is point O, this is X, this is Y. Okay, so here if P, okay, if this P is any point in the space, then the vector OP, okay, the vector OP, okay, the direction is this. This vector OP is called the position vector of a point P, where this O is called the origin of reference. This is called origin of reference. Okay, and this OP is called the position vector. Okay, if you want, just write down OP without writing the magnitude symbol. So OP is called here the position vector. All right, so this is our position vector. Okay, now because we have understood this, also remember, because it is on a space, so it will have the coordinates x comma y as well. If you are talking about 3D, so it will have x, y, z. Okay, now let us move to the last type of the vector, and that is called, any guesses? If you're watching my video, you can think or you can guess what I'm going to write down. The last is called colinear vector. Do not get confused, this colinear vector with the coinitial. That was coinitial, where we defined coinitial vector as two or more than two vectors are said to be coinitial vectors if their starting points are same. But this one is called colinear vector. Okay. So what are collinear vectors? Here also we will talk about more than two vectors. So suppose we have two or more than two vectors, and those two or more than two vectors are said to be collinear if they are parallel to the same line. Okay. So let me write down the definition for you. We have a very nice examples on, distinguishing the collinear vector, equal vector, coinitial vector, equal vector, zero vector, unit vector in NCERT. So here I'm just making you understand what is the meaning of collinear vector. But when I'll take examples where we have to find out whether the vectors are collinear or not, you will understand it in the best way. Okay. So right now I'm writing the definition. Two or more than two vectors are said to be collinear vector, are said to be collinear vector if they are parallel. Okay, if they are parallel to the same line, if they are parallel to the same line, irrespective of their magnitude as well as direction. That means the magnitude does not matter, the direction does not matter, it just needs to be in the parallel line. Okay, so here, irrespective of its magnitude and direction, very important point, magnitude and direction. Okay, if you have not understood about the coinitial vector, I'm going to make another video, like the second part of the vector, where I'm going to take questions of NCERT, where I'll be, explaining you about collinear vector, how to identify whether the vectors are collinear or not in that particular video. Now this is the end of the video. Okay, so at the end I just want to ask you, we have understood about a lot of vectors, but have you ever heard about free vectors? If you know what is the meaning of free vectors, or if you don't know, figure out what is the meaning of free vectors. I talked about a lot of vectors, but I did not talk about this vector because this work is for you. I want you to figure out, Google, and like open the books and find out what are free vectors. What is the meaning of free vector? This is your work. If you have understood my video, if you liked my video, don't forget to like this video and share it with your friends who are currently in, like 11th or 12th. So yes, and also if you have not subscribed to my channel, keep supporting my channel and don't forget to subscribe. If you have already subscribed, press the bell icon so that every time when I'll upload a new video, you will get a notification regarding the same. So yes, thank you so much for watching the video. Bye bye and see you soon in my next video.